Alright guys, welcome to this page of the notes. So what we're going to do is on the next couple of pages we're going to do a few proofs. Again, keep in mind that probably the distinction that your geometry teacher might make, I'm definitely going to make, is that if it is an honors class, I would expect you to write these proofs from scratch on your own, as opposed to if it's just a geometry class. I would give you sort of the bones of the proof and you would just have to fill in the missing pieces. Actually, what we're going to do here in this problem is get introduced, or I'm going to introduce you to a new type of proof, and it's going to be what we call an indirect proof. And here's the way that an indirect proof works. The way that it works is you are simply going to assume the statement that we're trying to prove is false. We're going to assume, right, whatever it is you're trying to prove, assume it's false, right? And then what we're going to do is we're going to logically work our way through the information using definitions, postulates, theorems, right? You got to use all the justification steps, right? But because I assumed what I'm trying to prove is false, as I work my way through the definitions, postulates, or previously proven theorems, hopefully what'll happen is I will reach a contradiction. You can conclude the assumption is false and the original statement was true when I come to a contradiction to what I assumed. I know that sounds like a mouthful. Let me show you how it works. It's really not that bad. Use an indirect proof. I'm given, right, PA is equal to PB. So PA is equal to PB. I've even shown you right there in the diagram. I've given you those indicators, those little hash marks to show you that they're congruent. I want you to prove P is the perpendicular bisector, right? Perpendicular bisector of AB. I want you to prove that line, P, is the perpendicular bisector of AB. Here's the way this works. Step one. Since we're doing an indirect proof, I'm going to assume what I'm trying to prove is false. Assume what we're trying to prove is false. So what I'm going to say then is, since I'm trying to prove P is the perpendicular bisector, I'm going to assume P is not on the perpendicular bisector. Let me clean up bisector. So I'm going to assume that P is not on the perpendicular. Since I'm trying to prove that it is, I'm going to assume that it is not. Therefore, what that means, if P is not the perpendicular bisector, then that means that Q is not the midpoint of AB. By extension, point Q is not the midpoint of AB. All right, that's step one. Simply, in an indirect proof, you simply assume what you're trying to prove is false. Right? Since I'm trying to prove that P is the perpendicular bisector and therefore Q would be the midpoint, I'm going to assume neither of those are true. I'm going to assume P is not the perpendicular bisector and that Q then is not the midpoint of AB. Now, step two. Right? Step two is simply this. I'm going to work based on theorems, definitions, postulates, until I come to some sort of a contradiction. All right? So here's what I'm going to do. The way that I would do this one is like this. We're going to use the Pythagorean theorem, and we're going to use the Pythagorean theorem twice. Here's what I can say about the diagram. All right? Here's what I can say. Right, I've got two triangles. I've got this triangle, AQP, and I've got this triangle, BQP. So I have two triangles. Now, I can write a Pythagorean theorem for all of those triangles, right? I can write a Pythagorean theorem for all those triangles. So here we go. For this triangle AQP, right, I'm going to do the Pythagorean theorem is the square of the legs. So A squared plus B squared is equal to C squared. Same thing for this triangle, A squared plus B squared is equal to C squared. Now, just plug that stuff in, right? I have a leg right here, AQ. So I will do AQ squared, right? Whatever this distance is, I square it. Add it to my other leg, QP. And square it, right? The other leg squared. That all has to be equal to my hypotenuse, AP, which I will square. Now, do the other one, right? Two legs. I have leg BQ, which I will square, plus leg, right there, QP, which I will square, which all has to be equal to my hypotenuse, PB, which I will also square. All right, so now what I'm going to do, now that I've written, right, a Pythagorean theorem, right, for both of those triangles up there in my diagram, what I'm going to do is I'm going to subtract these two equations. I know it sounds scary, it's not as bad as it sounds. Watch this, I'm going to take this equation, and from it I'm going to subtract this equation. Really, really simple idea. Here's how you do it. I'm going to take AQ squared plus QP squared equals AP squared. And I'm going to subtract from it BQ squared plus QP squared equals PB squared. Here we go. Right, I'm just going to subtract those two equations. Well, this is actually really pretty easy to do. Here's what I'm going to do. I have AQ squared minus BQ squared. Okay. AQ squared minus BQ squared. Okay. I have QP squared minus QP squared. Do you see that? QP squared, QP squared. What happens when you subtract something from itself? Yeah, those guys cancel each other out. That's zip, nada, bupkis, goose egg, zilcho, zero, right? They just cancel each other out. They're gone. So then I have equals. And then I have AP squared minus PB squared. Okay. AP squared minus PB squared. So there we go. Really not that terrible. I just used Pythagorean theorem to write out the legs and the hypotenuse for both of my triangles up there. And then I simply subtracted, right, those two equations from each other because the QPs are going to drop out. And here's what I'm left with. Now, hang on a second. Look at this. If I go back up to my diagram, right, please notice that AP and PB, I'm told in the diagram, I'm told that they are congruent. They're the same. They're equal to each other. AP and PB. So AP minus PB, they're equal. They're the same. Anytime you take something and subtract from itself, they cancel each other out. Guys, this again, those drop out, leave you with a 0 over here, right? So all that's left is AQ squared minus BQ squared. Add the BQ squared to the other side. AQ squared is equal to BQ squared. Take the square root of both sides. AQ is equal to BQ, and do you see it? What have we just done? Because I just reached a contradiction. Look, remember, in step 1, I assumed Q is not the midpoint of AB. Right? That was, I assumed Q is not the midpoint, which means that this segment, AQ, is not equal to QB. Those two segments are not equal, right? Because I assumed Q is not the midpoint. But look what we just showed. We just showed that AQ is equal to BQ. Right? I just did a whole bunch of algebra that's perfectly legit and showed those two segments are congruent. So I have now come to a contradiction. I assumed these segments were not equal, but I just showed that they are. So by indirect proof, I have shown that Q is the midpoint of AB, and therefore by extension, right? Remember, I also assumed in step 1 that P was not the perpendicular bisector, right? Well, if Q is the midpoint, then P must be the perpendicular bisector. So by indirect proof, I have shown that Q is the midpoint of AB and that PQ must be the perpendicular bisector. Okay, please, I know, indirect proof, I'm not suggesting that there's anything easy about that, all right? I'm not. It takes a lot of practice. We'll get practice in homework and stuff like that, but again, the key idea here really is this. Whatever you're being asked to prove, assume that it's false. And then you're just going to work your way through the proof until you come to a contradiction. Once you reach a contradiction of your original assumption, you have then proven by an indirect proof, since my assumption was false, the original statement must have been true. Q is the midpoint. P must be the perpendicular bisector. All right, so that's the way the indirect proof works. Head on over to the next page of the notes. We'll take a look at a couple more proofs that we're more familiar with. We'll do a couple of 2-column proofs. So I'll meet you guys on the next page.